Complex numbers, a cornerstone of modern mathematics, began as a tool to solve equations that resisted the efforts of the greatest minds. In the early 16th century, Scipione del Ferro, a mathematician at the University of Bologna, made the first breakthrough by solving cubic equations. Working in secrecy, he discovered formulas that handled specific types of cubic equations, a feat that he shared only on his deathbed with his student Antonio Maria Fiore. Fiore, armed with Del Ferro's formula, challenged Tartaglia, another mathematician, to a contest of solving cubic equations in 1535. Tartaglia, unaware of Del Ferro's work, independently derived the solution the night before the contest, winning decisively. Girolamo Cardano, intrigued by Tartaglia's solution, convinced Tartaglia to share his formulas under an oath of secrecy. Cardano later found Del Ferro's original work and, recognizing its priority, published the solutions in his 1545 book Ars Magna. Here, complex numbers suddenly entered the mathematical landscape, as Cardano encountered what we now recognize as the square roots of negative numbers. Raphael Bombelli, studying Cardano's casus irreducibilis, not only acknowledged the existence of these bizarre roots, but also demonstrated their utility, interpreting complex numbers like 3 plus or minus the square root of minus 15, in a way that made sense within the framework of Renaissance algebra. Descartes, later in the 17th century, coined the term imaginary for these numbers while discussing polynomial roots. Despite his skepticism, the term imaginary became a standard part of mathematical vocabulary. Complex numbers were initially viewed with suspicion and confusion. Yet, through the work of later mathematicians like Abraham de Moivre and Leonhard Euler, who connected them with trigonometry, these numbers gained a solid footing in mathematics, culminating in their essential role in modern physics, engineering, and beyond.